In general, cryptographic systems assume some level of trust. A prime example of this would be a secure key exchange. In such an example, the parties involved must be confident that they are in fact communicating with the intended party and not someone else. Even beyond that, the parties would want to be confident that there is no eavesdropping in the communication via a third party. While key models such as Diffie-Hellman help prevent eavesdropping, it does not guarantee that we're not communicating with an imposter. A model such as Diffie-Hellman, for example, eliminates the need for eavesdropping protection, but it does not, however, imply that we are communicating with the intended party. So let's quickly recap what implications this has. The challenge for key exchange is that both parties must be confident that they are communicating with each other. 2, they must be confident that neither is an imposter. And third, they must be sure that there is no eavesdropping in on the exchange. Let's take this a step further to better understand the basic trust model. When two parties engage in a transaction, they must mutually trust each other's identity. They must trust that both parties are allowed to engage in the transaction. They must trust that no third party can know the details of the transaction. There must be basic trust that no third party can change any part of the transaction. Fifth, there must be trust that neither party can deny having engaged in that transaction. And sixth, trust that the record of the transaction is kept for future reference. We have clearly identified the challenges associated with the basic trust model. So then how do we ensure that we are in fact communicating with the intended individual? One possible solution would be through personal knowledge. For instance, the two parties could meet at a coffee shop and have an in-person key exchange. But is this really convenient and/or scalable? Probably not. Another option readily available is the web of trust, which we will discuss next. And a third option is the public key infrastructure. A web of trust is a concept used in PGP and Open-PGP compatible systems to establish the authenticity of the binding between a public key and its owner. Its decentralized trust model is an alternative to the centralized trust model of public key infrastructure, which relies exclusively on a certificate authority or a hierarchy of such. As with computer networks, there are many independent web of trusts, and any user, through their identity certificate, can be part of it, and a link between multiple webs. A web of trust essentially works by having certificates signed by other users to endorse the association of that public key with the person or entity listed in the certificate. The drawback is that the user has to trust all those in the keychain to be honest, so it's often best suited to small user communities.